This is Donnelly, and before we begin, I'd like to go over some of the technologies with using GoToWebinar. In particular, you should be able to see the control panel pictured on the screen right now. If you don't, you may have it minimized, and you can pull it back out by going to the Grab tab, which hides and shows the control panel. There is also an attendee list where you can see all the participants on the call. And if you have a question, you can raise your hand by clicking on the hand icon on the control panel or by typing in your question into the question pane, and I can read it to the group or respond privately. All the panes may be expanded or minimized by clicking on the plus or minus buttons that are at the top left of each pane. And in the past, we've had some audio trouble. If for some reason you're experiencing any difficulty, you can always enter the audio pin provided to you at the beginning of the call. And if that doesn't work, you can hang up and call back in and be sure to enter the audio pin. So I will now turn it over to Lisa Nyssa.
Hi, this is Lisa Nyssa. I'm the Vice President of Strategic Partnerships at Achieving the Dream, and very pleased to have all of you joining us for our Technology Solutions webinar. This webinar has been put together by Caitlin Donnelly and by Carrie Henderson and Melanie Mulvey from our staff. Many thanks to them. And we have a terrific bunch of panelists and an exciting topic. David Morris with Eastern Arizona College and Professor Ariel Anbar from Arizona State University are joining Dr. Dror Ben-Anim, who's the CEO and founder of Smart Sparrow. You'll be hearing from them shortly, and they'll be talking about the very exciting new Inspark network. And after that, we will have a chance for any of you who would like to ask questions. And then we will do a short survey and talk about our next webinar. We have formed this technology series because, as you know, Achieving the Dream works with its network of community colleges to help them in many different ways to improve student outcomes, student success, student persistence. And one of the critical elements that we are focusing on at this point is teaching and learning, and that is how this webinar fits in. But in what we are finding is increasingly our colleges are looking for solutions that are enabled or powered or accelerated by technology. And so we started a series to be able to address technology solutions that in and of themselves are not necessarily the answer, but in combination with all the different things that colleges do to improve student success, they can really make a difference. So at this point, I'd like to introduce again Dr. Dror Ben-Anim, Ariel Anbar from ASU, and Professor David Morris, and turn it over to Dror to take it from here. What I am going to say, though, before I do so, is that we are very pleased to have Achieving the Dream, the primary technology partner with the Inspark network, bringing the network of community colleges that we represent into this network and making sure that they're aware of the opportunity. So we're pleased to do that now. So I'll turn it over to Dror.
Hi, good morning. This is Dror. I'm very excited to be here today. Thanks, Lisa, for this introduction. Today we're going to talk about a very interesting project called Inspark. And in this short presentation, I will, together with my colleagues, Ariel Anbar and David Morris, speak about something interesting that is called a teaching network. So what is a teaching network? It's a digitally empowered community of educators that are creating and sharing next-generation courseware and technology. And the Inspark Teaching Network is dedicated to post-secondary success of disadvantaged students in low-level science. This is, in fact, the result of successful collaboration between a few partners, including Achieving the Dream, of course, and this project is funded by the Gates Foundation. So without further ado, I just go ahead and introduce you to the network. This presentation is going to be structured as follows. I will be giving you a bit of background information that you may need now in order to understand what we mean when we talk about next-generation courseware. After that, I will hand it over to Professor Anbar from Arizona State University. Sorry, I will be talking about the technology. I'm sorry for that. Professor Anbar will be talking about what is next-generation courseware and specifically for science. Well, then Professor David Morris will present the community college angle and why this is such an exciting opportunity for community colleges. All right, so we're going to start with a bit of background about Smart Sparrow. So what is Smart Sparrow? Well, Smart Sparrow started as a research center at the University of New South Wales, which is a university in Sydney, Australia, between the years 2005 and 2011. The work of the research group that I was heading at the time focused on the intersection between artificial intelligence and education. The idea was, how can we make computer technology that help teachers teach better, online? The mission of the company was to make the world smarter, a very ambitious mission, because we believe that the smarter world, of course, is a better world. But how are we going to make the world smarter? And this is where I think we're slightly different, because we really believe that the way to achieve that is by empowering teachers to teach better. So using technology to empower teachers. What does it mean? Well, at least our ideas is that if you build technology that promotes learning by doing, that makes learning experience personal and adaptive, and again, that empowers but not replaces teachers, you get a good chance of making the world smarter. We have a software platform. We call it the Adaptive Learning Platform, and it is a platform for next-generation courseware that is rich, interactive, and adaptive. Smart Sparrow has users in more than 500 institutions worldwide and have a specific focus to date in the sciences, medicine, and engineering disciplines, and I think you will see immediately why. So what exactly do we mean when we say rich, interactive, and adaptive? Let's dig a little bit deeper into that. So first of all, we all need to get to a shared understanding of what we mean when we say when we talk about an adaptive lesson. So the best way to think of an adaptive lesson is that it is an online lesson that is changing based on how students interact with it. The schematics over here essentially gives you a representation of that. It is made out of screens. Each one of those squares is basically a silver screen. Screens can contain information such as text, images, and video, but to make it adaptive, students need to interact with the lesson, which means that screens also include what we call input widgets. It can be buttons, multiple choice blocks, sliders, and so forth. The nice part is when you sort of visualize like that, you can also imagine screens that have very rich simulations like that. Okay, but what makes this adaptive? Well, the learning is adaptive in two ways, really. The students will get adaptive feedback. So the little feedback icons on those screens represent the idea that each student will get different feedback as they are working in that part of the lesson. But also the sequence of lessons, or what we call the lesson pathway, is also can be adapted to individual students based on what they do and based on what they've done in the past and what they know and so forth. So here's an example of what we mean when we say a rich, interactive, and adaptive lesson. So in this screen right here that is taken from a first-year science course, students need to learn by doing. In other words, they can't just read something and progress. They actually need to solve a problem, and they have to solve the problem by actually interacting with the simulation on the stage. Now, the feedback that the students are getting here on the bottom right is contextualized to the student's action. It's a different. I get a different feedback from my friend because I get things, wrong in a different way. I make different mistakes. I have different previous knowledge. Of course, the next screen that I will experience in this lesson would be also dictated based on what I'm doing here. So it has also this idea of adaptive lesson pathway. Another example of a rich interactive and adaptive lesson is a virtual lab. In this case, this is first-year biology students who are learning about photosynthesis, and they perform a little experiment. This particular screen in this adaptive lesson has both a simulation on the stage, which is the interactive bit, as well as text you can see on the left. It's important to note that the text was created by the subject matter experts, in other words, the teachers, while the simulation was created by a developer. And the idea is that the collaboration between developers and teachers become much more streamlined and efficient. You can really get to fantastic results like that. And you will see much more many examples in the next few slides. So again, in similar way to the previous example, it's learning by doing. You actually have to do an experiment. You can get it wrong in many ways. Each different way will give you different feedback. And also we'll be able to decide what's the adaptive lesson pathway that will happen based on your interaction. So these are just two examples out of many such online, rich, interactive, and adaptive lessons. At Sparrow, as a research center and as a company, we were fortunate to collaborate with many professors who created these lessons. And we found the process of empowering instructors, professors with the instructional designers they need, with the developers, to be a very efficient way to achieve this great outcome. I mentioned until now that adaptive lessons. Is it possible to create a complete adaptive course? Well, a few years back, I was introduced to Professor Amba, who asked us if it's possible using Sparrow to build a complete adaptive course. My answer was, of course, even though it was an early stage of the company, and we had to, of course, build the capability as we were going along. But the result was fantastic. This is a habitable world. It's a complete rethinking of how we teach science online using really rich interactive and adaptive learning experiences. And Professor Anbar is going to speak more about it in a few minutes. So if you want to understand what we mean when we say a platform for next generation courseware, first of all, we define what next generation courseware means. We're talking about learning experiences that are rich, interactive, and adaptive. So we all agree on a definition. And you can think of Sparrow as the tools you need in order to create this type of learning experience and give them to your students. And if you want to compare it to current generation courseware, you can think of the LMS as the current platform that is used in order to create learning experience, current generation learning experience. So what sort of platform? What does it need? Well, if you're talking about a software platform, you need tools that enable you to create rich, interactive, and adaptive courseware, deploy it to your students, analyze how your students are learning, and also share it with your colleagues. So I think it's interesting because the fact that there's a software tool that lets you create, deploy, and analyze means that instructors can continuously improve the courseware to better suit the students' needs. And they do that through an iterative process of deployment, analysis, and adaptation. In other words, this is not static content, get produced once and launched and never be looked at. It actually keeps being improved by the teachers as they keep understanding and uncovering the student misconceptions and learning what's the best way to teach their students like that. In order to do that, we've got, of course, an authoring tool here on the left. It's not so different than PowerPoint. Instead of creating a presentation, you're creating an adaptive lesson. It's what you see is what you get. You can see how the screen is on the left over there, and we are currently editing a particular screen. And the panel at the bottom is called the adaptivity panel. And this is basically the tool you use in order to create the rules that describe how this lesson will adapt to your students. In other words, what's the adaptive feedback we give, and what is the adaptive pathway decisions. And it's important to understand all these capabilities, all this control is at the hands of the educators. On the right, you see one of the many analytics tools that we have. This one actually shows you what the different ways in which your students flow through this screen. Some of them getting it right away. Some are getting mistakes. You see us represented as flowing into a red box. And then after getting mistakes, students are being corrected because of the adaptive feedback and getting it right. And some students, of course, it takes a few times until they get it right. So I talked a little bit about the fact that the teaching process is cyclic, but it turns out that Sparrow is also interested in this idea of creating and sharing next-generation courseware, which is very different to the publishing model, right? We have the publish model, and we've got the create and share model. So what happens, turns out, that when you give the capability to create and share to instructors, what actually emerges is what we call networks of teachers or teaching networks. Turns out that teachers are very happy to share content with their colleagues. Well, if you think about it, that makes sense to collaborate. Of course, it reduces costs to individual schools and individual departments. But it also means that we can propagate more effectively the best practices and research findings about what's the students' misconceptions, what's the best way to address those. And of course, we are reducing our effort. As a result, it's possible to raise the bar across the board. It means it's possible for a whole discipline of teachers in various institutions to get together and improve the way they teach together. Over the past few years, we've been fortunate to collaborate with a few such teaching networks. And the first one was Adaptive Mechanics. This was actually 7 engineering schools that shared 12 rich, interactive, and adaptive lessons. Because we're targeting the first-year mechanics course, which has a very high failure rate. And in fact, in one of the studies, and this is published research, the professors found that by introducing these adaptive tutorials to the students, they were able to reduce the failure rate in their class from 31% to 5%. Now, the reality is that there's no magic here. Students were given homework activities that are adaptive lessons. That means that the student is sitting at home and solving through problems by interacting with an engaging activity while being given intelligent feedback and adaptive remediation, so feedback and pathway. As a result, students are more engaged, but in reality, they also do their homework. And it's no secret that when students do their homework, they perform better. And this really shows that. It's the same teachers, and it's the same teacher, and it's the same exam. Another example is the Smart Science Initiative. Here we had 4 high school students, 30 high school schools that were collaborating with 4 science faculties, and I mean like a department in the university. But this network I really want to mention is the BEST network. I think it's an interesting case because first, BEST stands for Biomedical Education, Skill, and Training. It was funded by a government grant in 2012 with 10 medical schools and 1 tech partner. The concept was to establish a network of biomedical schools that will share next-generation courseware and technology. The rationale was simple. If they collaborate across geographies, they'll be able to improve the discipline as a whole, the teaching of medicine as a whole. But the key thing to understand that it was not only about building courseware or technology. Really, it was about supporting teachers to use technology in the classroom through training, through seminars, and so forth. The BEST network would start with about 5 professors with a vision. It now has 1,100 instructors from 200 schools that are creating and sharing more than 100 rich, interactive, and adaptive lessons that cover the first few years of medicine. It is set up as a non-for-profit. The BEST network is a non-for-profit that is directed by the leaders of the discipline and recently entered the U.S. If you're interested to learn more, you should check the URL at the bottom, best.education.eu. So this is my summary. I was striving to introduce you to Smart Sparrow and tell us about our mission, explain what is rich, interactive, and adaptive courseware, mention that how the platform that supports that is for creating, deploying, and analyzing these, and talk about the continuous improvement of the teaching process and how the ability to share really yields and results in teaching networks. At this stage, I'm going to hand over to Professor Anbar, who's going to talk a little bit about next generation courseware, why it's important, and what can you do to science teaching. Over to you, Alred. Thank you.
Great, thanks, Dror. So what I'm going to do here is pick up from where Dror left off. So he gave you a nice overview of the technology behind this project, and what I'm going to do is talk to you about the kind of courseware that we're going to produce and distribute on this network. So that courseware is modeled after a project that we worked on with Smart Sparrow that Dror alluded to at Arizona State University with support from NASA and the National Science Foundation, a project called Habitable Worlds, which we regard as the prototype for next generation courseware. So what is Habitable Worlds? Well, first of all, it's a transdisciplinary science course for non-science majors. It's not a course that is stuck in a traditional disciplinary box. And it has a number of design features that we regard as critical. First, it explores a big question at the frontier of knowledge. It's not about communicating what's known. It's about helping students see what's unknown and engage them in the challenge of understanding that. It's organized around an integrating project in which students apply the knowledge that they learn as they go. It features the sort of rich, interactive, and adaptive lessons that Jor talked about. Those lessons feature beautifully designed scientific simulations, again, along the lines of the ones that Jor has described. And students and staff involved in this kind of course are supported by networks. This is not a situation where we deploy and let students sink or swim on their own. We support the students, and we also support the staff who are teaching this in various ways. And we think that these design principles all add up to a better way to teach science. And we think it's better because it addresses some big problems in the way science is taught today. So one of those problems, which many of you are familiar with, is the lecture model. The lecture model is really a dismal way to teach science for a number of reasons. First of all, it's inherently a passive rather than an active approach to teaching. That's pedagogically challenging to begin with, but it's particularly bad for science, which is an active endeavor. Science is not about sitting back and receiving wisdom from authority. Science is about exploration of the unknown. It's not about accepting what is known, and the lecture model works against that. In addition, this kind of model, it turns off STEM majors, and non-STEM majors aren't really pulled in. They don't really get exposed to what science is all about. And it's especially bad for underprepared students, students who come to college not really acculturated yet to the idea that sitting in a lecture assimilating the basic concepts of, let's say, chemistry, of introductory chemistry, is a useful thing for them to do. And one of the reasons, in addition to just the lecture model, this is problematic is because the way these courses are typically delivered is through this sort of siloed curriculum. Right? The problem is that the questions that we care about, frankly, as researchers, and certainly that students care about when they come to college, again, unless they've been already acculturated into a disciplinary worldview, don't fit in silos. Right? The questions we care about don't fit in silos. These silos exist for the convenience of academics, but in fact, not even modern academics. They're really historical legacy in many cases. So the questions that we want to organize curriculum around cross through these disciplines and integrate them in various ways. So what we developed at ASU in Habitable Worlds was a very different kind of course concept. And the heart of the course is shown here in this slide. The course is kind of like a game. The course is organized around the notion that you want to find and characterize habitable worlds in the universe. This is a cutting-edge area in science right now. And the students are confronted with a game in which they each gets an individualized field of stars like this. And they have to search this field of stars for a habitable world and characterize it and see if it might be inhabited. And, of course, they don't have any idea what to do here, and that's the point. And what we do then is we bootstrap this with lots of rich, interactive, adaptive lessons that teach the students the science concepts they need to learn in order to navigate this game. So both the lessons and this game-like project itself both feature lots of interactivity, lots of adaptive feedback to motivate students and help them master the material. So we've taught this course now to nearly 2,000 students over 6 semesters. We're about to enter our 7th. And we get very powerful anecdotal feedback. We get comments like this: I was able to open up my mind to topics that have always scared me, science and math, and I learned that I could enjoy it and that I was capable of doing it. And we get these kind of comments unsolicited. They come in emails from our students. They come in discussion board posts, especially towards the end of the semester, where we get students saying, hey, I've really enjoyed this course. Is there a sequel? Is there something else I can take? And these are not science students. These are very often students who are science interested, but they've been science alienated through their courses up to this point. So we're in the process of getting objective evaluation from this, but the anecdotal information is very powerful. So how does this apply to the Inspark Science Network? So just about everybody teaches still in disciplinary silos. So how can we take some of the magic of this course of the Habitable World and apply it in a way that actually is adoptable by folks in the way they teach today? And so what we came up with is the notion of what we call smart courses. So what's a smart course? So a smart course begins with a big question, a question at the frontier of knowledge, like, are we alone in the universe? And it has to be a question that can be disaggregated into multiple streams of inquiry. So you can imagine a stream that, like Habitable World, which covers many different science topics around the question, is anybody out there? You can imagine another stream that's physics-focused, that's more focused on how we find planets around other stars. You can imagine a chemistry stream, which is focused around understanding which worlds are habitable. That's a very chemistry-oriented question when you dig into it. And you can imagine another stream that is biology-focused. Can we find life? Which requires you know a lot about what life is. Each of these streams can encompass all the learning objectives of an introductory disciplinary course in physics or chemistry or biology or other subjects as well that we could cover. And so what we are doing now, and what we will be doing over the course of this project, is creating courseware that organizes the learning objectives of these intro courses into what we call missions. Each one will be sort of goal-directed and project-oriented. Within each mission, you will have a number of rich interactive adaptive lessons of the sort that we've been talking about that teach the basic concepts you need to know in order to master the missions, which are designed to help the students answer the question. And all the information that they learn gets applied to projects along the way. So each one of these streams here can be thought of as the equivalent to an introductory level course. So this Can We Find Life Biology stream, for example, which is the first one we're building, encompasses all the learning objectives of introductory biology, but motivated by this big question that most students coming to college can relate to at some level, and many of them are very passionate about. So how do we do something like this? I mean, that's a huge curricular design challenge. This is not something that just one person can do. And it's not something that really just one person can support. This is very much not a MOOC in that sense. And so what we realized right away as we conceptualized this is what we really need in order to build courseware like this is we need a network. We need a teaching network of the sort Dror was describing, a network that can share tools and share content that's built with those tools. And the philosophy that we have here is that if we want students to learn at scale, then teachers need to learn to work at scale too. And a little bit more schematically, you can think of this as a network of educators, scientists, evaluators, and partner institutions, science educators, production partners, research and evaluation folks, teaching partners, network developers, all working together to build these smart courses to serve students in the various disciplines. And when we say network, we don't just mean an email list of people talking to each other. We mean a group of people powered by a digital platform, like the BEST network that Dror was telling you about, the platform that allows them to take this kind of courseware, create it, create new aspects of it, share it, modify it, deploy it, and assess to get that cycle of improvement. It's a decentralized and collaborative approach to developing and deploying and improving online courseware. So this Inspark network, it already exists. It's already here. There are 25 teaching partners already that we're interfacing with via Achieving the Dream. They represent about 200,000 first-year science students, about half of whom are low-income and disadvantaged science students based on Pell Grant statistics. And so this isn't just something on paper. It's something where we already have folks who are very excited and interested in offering this kind of courseware. We just had a workshop here at Arizona State University where we had about 200 faculty and administrators from around Arizona and a few other places at community colleges interested in learning how they can leverage this sort of courseware, and we already have a few pilot adoptions going on. And just to finish my portion of this with a little inspirational ending quote, this is a nice quote that encapsulates what we're trying to do here. Progress comes when you find a solution by seeing the problem in a new way. That's innovation. When you reinvent the way you educate, the old assumptions about time and cost and method vanish, and you break through. And that's a quote from Bill Gates, who is providing funding for getting this off the ground. And so what I'd like to do now is turn this over to David Morris. David is a professor at the Eastern Arizona College here in Arizona, one of our neighbors here. And he's going to tell you a little bit about, from his perspective, he's one of our early adopters, early pilot adopters, the value of this sort of courseware and the potential of this sort of network at the community college level. David?
Hello, everyone. Thank you, Ariel. This is David Morris from Eastern Arizona College. And I'd just like to talk a little about our involvement as a rural, small to medium-sized community college, what it is that attracted me and others at the college to the Inspark network, and how we're looking at employing the Habitable World curriculum. I don't currently have screen control, so if you could work on that for me, Caitlin or Lisa, and forward me through to the first slide. We're particularly dedicated to reaching out to disadvantaged and underserved communities at Eastern, because that's really where we live. We're in a rural community among some of the poorest of counties. So socioeconomically, we're challenged. We have some cultural challenges, but we're very dedicated to offering access to college-level science to that entire community. In particular, over the past decade, or perhaps a little longer, we're seeing an increase in the number of what I would consider to be underprepared high school students coming in. So reaching those students and helping them achieve success is a big issue for us. The particular point of interest that really grabbed me with Inspark and with Habitable Worlds was distance education. We have a distance education program that is considered by our reviewers and auditors to be quite successful. and yet most of us in the science division are not very satisfied with it. I describe it as a distance education program that fails to go the distance, a track record that really falls short of the mark. The failure rates in our online science classes are significantly higher than the failure rates in our on-campus science classes. And that's obviously a concern. But an even greater concern is the student feedback from our online science classes indicates to me a failure to connect. The most glowing feedback we get is simply an expression of gratitude that the students were able to complete a 4-unit general education lab science class in an online environment. So we never get these sort of rave reviews that we do get in our face-to-face classes, our experience-based face-to-face classes. We get reviews that are just wonderful and glowing, and you know, talk about changing viewpoints and really changing a whole outlook on life through completing those classes, life-changing experiences. We have this demographic that is essentially unchanging. We've got 40,000 potential students really within our backyard or in our local neighborhood that are not being reached. So I'm looking for ways to reach that, and this technology promises some of those opportunities to reach those people. I've always seen science, and the thing that's attracted me to science is the exploration. I've never understood science to be an excavation of the knowledge of the past, and yet too often that is what our online classes are, as well as online classes that I review for other campuses. They're of this format of read a chapter, take a test, read a chapter, take a test, end of the semester, take a comprehensive final, and you're done. And I think that's a very dry and very false experience. So looking at the Habitable World curriculum and looking at the other projects that Inspark is working on, seeing something much more engaging and immersive and really much more changing. The idea that a class could possibly change your life, I think is very exciting. So I first experienced Habitable Worlds in an introductory seminar on the ASU campus, and I immediately related it to my experience with a video game called Portal. And many of you have probably seen Portal. It was a very popular game a few years ago. And it just felt to me like I had the same level of immersion, and yet I was being challenged. The academics were there. It's a rigorous course. And yet it was very engaging and very challenging, and actually got my pulse up playing with it. So I was immediately hooked, and I've been working on implementing that software. So let me bring you up to where we are right now. This semester, I'm taking this a la carte approach to the software. So what I'm doing is taking my existing astronomy course and removing modules from the course and replacing them on an a la carte basis with the lessons from Habitable Worlds. And this sounds tough, but I've got tremendous support from the Inspark Network. As I move forward, I have a summer school offering that will continue that same process. I think I'll be at around 60% Habitable Worlds curriculum in that course for June. And then entering into the fall semester, I should be running a 100% Habitable Worlds curriculum for all of my online science, online astronomy courses, with some customizations that I'll need to work on in the summer. So with those implementations, I'm hoping that we'll start to see some of this incredible feedback next year, and I hope to be able to get back to all of you with some real data results, both in terms of student evaluation numbers and retention rates. We should have some of those numbers by next spring. And with that, I'd like to turn you all back over to Caitlin Donnelly at Achieving the Dream.
Yes, we'll open the floor up now.
Sorry, this is Lisa, and while I give Caitlin a chance to collect the questions from the audience, I wanted to start out with one of my own. Thank you very much, Dror and Ariel and David. And I think one of the questions that immediately comes to mind is, how does this compare to a MOOC, or might it be better than a MOOC?
Sure, this is Ariel. I'll take that one. Yeah, so when we started building this course, Habitable World, here at ASU, before the whole MOOC business came along, and we kind of watched the MOOC peak, crest, and then fall, and watch it with some amusement, because Habitable World alone, we were already thinking of this has a very different philosophy than MOOCs. You know, our goal was not to create something and deploy it, forget about it, and not really support it all that much, and just see if we can get as many enrollments as possible. You know, the goal was to actually leverage the technology to try to teach better, and also as part of that to do it at greater scale than we normally teach. But scale wasn't the goal. And as we developed this whole Inspark concept, the notion that we had was, well, we're trying to build a network that allows teachers at other institutions to do something more than just take the course that we built at ASU and just offer it as a clone of that course. Who wants to do that? I don't want to teach somebody else's course. You don't want to teach my course. You may think that my course has some really cool elements and you'd like to adapt it to your circumstances, and the network and the authoring tools allow that to happen. So everything from at the lowest level, replacing my talking head videos with yours. We don't actually have a lot of talking head videos, but we do have some that frame the lessons. Those don't have to be me talking. Those can be the professor at the community college or at another university talking. But that's just the lowest level of adaptation that's possible. We all know that different demographics of students are going to respond differently to different sorts of feedbacks and commentary, and so it's quite possible, it's quite easy to edit the language of the text. So if a feedback, it has wording and language doesn't quite work for your students, you can go in and fix that, or maybe not fixing it, modify it, adapt it for your particular needs. And then beyond that, if the logic of a lesson doesn't quite work, right? What works at the research university with our students may not be quite the right fit for students at a community college working with students who are coming from a very different background. And so the very logic of the lesson may need to be rewired, and that's possible too. And so this is not a one-size-fits-all philosophy, which is the typical MOOC philosophy. It's on the contrary. It's a let's seed a network with the concept of let's seed a network with some really good stuff that can be adapted and modified and evolved. And our vision is that over time, the Inspark network will probably be hosting multiple versions, multiple flavors of HabWorld, multiple instantiations of it that will work, that will be optimized for the different sorts of students, different types of learners, different types of institutional settings that are out there, and each one of those will be better for its purpose than the initial courseware that we're going to be putting out.
Great. And we have another question on the adaptive learning graph. How do we know students are really thinking critically as opposed to just guessing their way to the right answer? What are the possibilities?
Ariel, do you want to take that?
So I could. So I'm trying to parse the question a little bit. Is the question, how can we tell whether they're guessing, or how can we encourage them to not guess? In the latter, let me focus on the latter, because that's a question of pedagogical design. So, we design most of the lessons so that you can't just guess your way through. You typically have, there'll be pieces where you can guess, but the critical path pieces involve simulators that you have to, with nearly infinite variability in what you might do, where you might put something, where you might move something, how you might adjust something, and unless you actually can think through how to come up with the right combination of parameters, guessing is just not a very good way to go. So for example, the central project that I talked about, where each student has a field of stars where they have to find an inhabited world, we've deliberately rigged that to be over 500 stars for each student. And we've rigged that way because if you want to try to go through and just do this as a guessing game, you're not gonna be able to do it. It's just too much. It's too many things to have to guess through and go through. And the project then really rewards students who understand the science well enough to be able to, first of all, narrow down the field of stars to those that are most likely to have planets, and that's based on having to understand some basic astronomy. And then, in terms of figuring out where there are planets there, they have to understand how we detect planets around stars in order to use the tool properly to be able to actually tell if a star has a planet around it, and so on and so forth. So at every step, students are applying what they learn, and in a way that's rich enough that a guessing game is not going to get them there.
If I could add something to that, just as a first-time user, the guessing isn't fun, but the exploring is. There's something inherent in the software and in the programming that following along and exploring and actually making progress is vastly more rewarding than just guessing. So again, I hate to use the example of Portal or a video game too much, but it really speaks to just how engaging the program is. Guessing gets dull very, very quickly and is not fortuitous. It doesn't pay off. But following does. It leads one to the next to the next. It's very, very engaging software.
And I want to give credit to where it's due to somebody who's not actually on this call, Dr. Lev Horodisky, who works with me here at ASU. He's been the one who's been very hands-on building this. I mean, we designed this together, but he's the one who has been hands-on working with the SmartStore platform more than anybody to build this. And he's a gamer, and so he brings to the course, a certain sensibility that, frankly, as a 47-year-old professor, I don't have. But he's substantially younger and much more in tune with that world, and that sensibility shows up in there. And so that's another sort of cultural thing we're trying to do here. We're trying to meet the students, in their reference frame, not force them to step up to or step down. I don't know if it's up or down to the reference frame of middle-aged science faculty.
Okay, this is Lisa, and we're out of time for questions. Thank you very much to the presenters, and for those of you who have questions that we haven't been able to answer on the webinar, if you have sent them in, we will be able to get them to the presenters, and they can get back to you following the webinar. And Caitlin, at this point, I know that you have a quick survey you'd like to run.
Yes.
And then we can wrap things up.
Yes, we have a quick poll that I'm launching now for you to answer. So the questions are, one, I would like to learn more on the Inspark Science Network. This call was useful and informative. I enjoyed the webinar format. There was enough time for questions and discussion. This call did not meet my expectations. So just check off the ones that you agree most with. And all that apply.
Okay, this is Lisa Nyssa, and I wanted to thank all of you very much for joining us today. The Inspark Science Network welcomes you to join your institutions, your science faculty, and is very eager to hear from you. To learn more or to follow up, please visit the website for the Inspark Network. And also, please consider, if you are not already registered, for coming to the DREAM conference in Baltimore on February 17th to 20th. Please come. There will be a booth there where you can experiment with the technology and the courseware and talk to all of the people that you've just heard from. There'll also be a session on this, and it would be great to have you follow up either between now and then or at DREAM. Our next webinar is going to be March 18th. And it will be with Houston Community College and Pearson, looking at how one can gather and effectively use student readiness insights to improve student outcomes. Thank you very much again to our presenters, and thank you to all of you and to Caitlin for organizing all of this.
Thank you.
Thank you, everyone.
Thanks.